Hello and welcome back to the Fermion YouTube channel. My name is David Flanagan and I am here to continue with our livestream series on the Advent of Spin. What is the Advent of Spin? Well, if you've not been following along, it is a series of small challenges to help introduce you to WebAssembly and the Spin framework. This is Challenge 2 walkthrough. So on Monday, I walked through Challenge 1, which speaking's hard, which seen us set up a Spin application with a JSON API that printed Hello World. Today, we're taking on Challenge 2, which is going to continue on from where we kind of left off with this very simple application with one component. And today, we're going to explore how we add a second component to a Spin application. This is also very exciting because just today, this afternoon, I read on the Tinterwebs that Fermion released the Node.js/TypeScript SDK. Now, this has terrible idea written all over it. I've never seen it before. I've never played with it before, and I really want to. So I think we're going to get a 2-for-1 today. As I take on Challenge 2, I also want to explore the TypeScript API. For anyone who's familiar with me and follows me on Twitter, it's no surprise that I love Rust and TypeScript equally. I think they're both phenomenal languages. So I always jump at any chance I can to write some TypeScript code. So if you're following along today, if you're watching this video, please feel free to say hello into the comments. And we're going to just share my screen and start writing some code. So let's pop us over where you will see that we have the GitHub I should just give up. It's a Friday, isn't it? github.com/fermion/advent of spin. The third challenge is already up. That went live this morning. So if you're already completed Challenge 2 and you're moving on to Challenge 3, best of luck. I'll be walking through that on Monday. Today we're going to focus on Challenge 2. This challenge will introduce us to extending Challenge 1 with root parameters. So looking at how do we parse and get that information, which I've never done with the TypeScript SDK because it's brand new. So I'll be learning at the same time. We're going to add a second component to our application, and we have to make an outbound HTTP request to another service. So there is a lot to cover. We're going to do this in under 30 minutes. That is the goal with Fermion Spin, Advent of Spin, is to introduce you to it with these simple challenges so you can get a feel and a taste, understand how interesting WebAssembly can be. As always with these challenges, we have a simple spec. This one says we can use any language that we want. Yes, we're going to put that to the test. We must return a 404 on the root. That's fine. We must have an endpoint /lowercase, which accepts a JSON payload, which we are going to lowercase any value given to us. And we must have another endpoint, which is /hello, which will return hello blah as a lowercase string. Awesome. Nice and simple. Let's dive into this then. So I have Challenge 1 here. What we're going to do is create Challenge 2. I'm going to go to Challenge 2 and we're going to start from scratch because I want to play with this new TypeScript SDK. Now, I do have the article from the Fermion website here, which tells us everything that we need to know. So we need to install the JS2Wasm plugin. So I'm going to run this. Yep. Woohoo! All right, and then we will need to install the SDK, although it looks like there is a template for building a Spin application with the JavaScript SDK. So why don't we use the template? That's what they're there for, right? So now we can do spin new HTTPS TS HTTP. I always make things hard for myself. All right, and let's call this lowercase. Well, let's start with the lowercase service first. because it doesn't have an outbound request to make. It's just going to take in a JSON payload and return it as a lowercase string. This should be nice and simple, and hopefully, don't want to get too confident, we should be able to do this in a couple of minutes. So the base and the path don't matter right now because it's a single component spin application, but as we add that second component, we will need to tweak that spin.toml to do our bidding. So I've never seen what a TypeScript spin application looks like. So let's see what we have. And I'm going to go ahead and just to make one change. I'm not going to, well, I am going to modify the spin.toml actually. I'm going to just pull it out of our lowercase and we'll update the paths just so we are kind of prepared. So, all right. Our trigger is going to be lowercase. We are going to run an npm build. We've got some sort of target. So this looks like it's going to be using a tsconf. This is going to dist. Maybe Webpack's doing something. No, dist as well. I'm not sure this is correct. So let's debug it, right? We're here, and if I do a spin build, this is going to fail because I believe this is going to run the npm command in this directory, which I would expect. However, our code isn't there. Yep. So if we do npm run, so we could set it up as a workspace and tell it to use the workspace, right? So let's do that. I haven't done this before either, so I'm in completely new ground at the minute. Workspaces. Is this a string? No. Let's look it up. I told you I was going to regret this. Ah, there we go. Thank you, internet and documentation. So we're going to have the workspace, lowercase, and this is spin challenge 2. All right. So now if we modify our spin.toml, we can say npm workspace lowercase run build. Can't type, can't talk. Just not really got much going for me today, do I? I haven't run an npm install, so I'm curious what's going to happen here. Nothing. Oh, no, okay, it's doing the npm install. There we go. Yeah, I was only a little bit worried. Wasn't worried at all, honest. All right. Do you want to install the Webpack CLI? I mean, if I must. So I did notice that we do get a Webpack config, but all it's doing is transpiling the TypeScript to JavaScript. I mean, I'm going to have to experiment, and maybe we'll save this for Monday or maybe next week episode where we just don't use Webpack and maybe use something like Deno, maybe Bun, Vite even. Like Webpack to me is 2020. I think we're 2022 now. So yeah, going to experiment. There's lots of really cool things happening in the JavaScript and TypeScript runtime space right now. Hopefully my internet can handle an npm install. Who'd have thought something would be slower than a cargo build? Maybe I could go make a coffee. Let's pop open a new pane. And I'm going to go into this workspace and I'm just going to run the minute I do that, obviously over there it starts going nuts, right? Okay. So why did you fail? So this is related to npm not being able to find a file, cannot cd into challenge to node modules yet because I moved it. This is what I get for going rogue so early. So I am just going to do a npm run build from here. Yes, install the Webpack CLI. Oh dear. You know, I was feeling far too brave, wasn't I? I'm going to delete everything. Let's not break it this time. Okay, lowercase. Spend, oh, cd lowercase, spend build. Let's do yes. Hopefully this is a bit happier. Tap it. Not sure what it's doing at this point. Last time I opened a new tab and it scared it into submission. Oh, maybe that's what broke it. The npm install ran just fine. So it's on a run build. It could be that JS to WASM is just a little bit slow. Did I miss any steps? No. Oh, it failed again. Okay, let's try run build. Oh. All right. As long as I don't touch anything, things work. So let's keep that in mind. Let's try a curl HTTP localhost 3000 on hello, and we get hello from the TypeScript list. Okay, we can work with this. So let's go back to our VS Code where we have the lowercase service, and there is a target directory. I guess the JS to WASM is doing that, but I don't know where that's configured. So I'm just going to ignore it for now. Now, our mission is for slash to return a 404, which it should already be doing because of the way that we have the spin.toml configured. So let's just turn on the V and actually make sure I'm still running spin. And we do get the 404. Now this is because in our spin.toml, we say that this component only listens to slash hello. There isn't any component configured for the path slash, so we get the 404 for free, which is cool. So now we need to make sure that on the lowercase endpoint, we return a content type header and we post a message like so. So we can just copy the spec to here. And what we need to do is update our spin.toml so that this component is lowercase. Now, the lowercase is going to accept a payload. So this is a body payload over a post request. So I'm going to define some sort of input payload, and this is going to have a value property, which is a string. So we define an interface for that. So down here, we can say that our input is equal, and what we want is our request.body, a string. Let's see what the types are. It's an array buffer. Okay. Let's do JSON and see what type we get back. We get an object. So told you I was going to regret this SDK decision. Let's see. It's just going to give us an object. I don't think I can do any sort of generic fancy stuff to cast that to a type or ensure it's of a type. Now, what I could do is just grab the body, which is an array buffer, and if we want to pull this in, you know, we could do a JSON parse manually and cast it to the type. But I'm not that fussed, and I want to finish this in 30 minutes, and I'm already 20 minutes in. So we're just going to do, this is a JSON, take the object. I wonder if that Copilot's trying to tell me this as is going to work. Hey, let's try it. Then we're going to say lowercase equals input. Thank you. We see the two lowercase function is available on a string with TypeScript. And then our response needs to be message. So we can define another interface, which is our output payload, which is going to be message string. Copilot, you're too clever. And down here, what's this encoder? This is a text encoder. The text encoder. No idea. Let's see if we can do JSON.stringify and then our output, and our output is going to be a output payload with message lowercase, like so. This might work. So let's jump back over to our terminal, npm run build. It didn't yell at me. Let's jump over to GitHub, where there is a test suite. So let's copy this. To here. So test.hurl. Now we've only made sure that this check is going to work. So none of these are going to work yet. So let's just, I don't think there's comments in our hurl file. So what I'm going to do is say temp, and we'll stick these in here. But what should happen is we should get the 404 on the root. On lowercase, we're passing in the expected payload, and we're going to assert that we get the lowercase version of that string back under the key message, and we've not got our response header yet. So let's throw that on. So content type application JSON. So we can do a npm run build one more time. And a spin up. With this, we can spin up a new tab, and we can say hurl test.hurl. Oh, it's in the other directory. Oops, what did I get wrong in my test suite? Well, this should be a post. Oh, we didn't specify that we expect a 200. Passed. Awesome. So we're almost there. So let's go back and copy the spec for part 2. Expose a hello endpoint and we want to do an outbound HTTP request to the lowercase service, lowercase the string, and return it. So let's create a new service. Okay, what language do we want to use? Let's do spin new HTTP REST. We'll call this hello. And we're just generating a completely new spin application, but we're going to tweak this now. So we have hello here. And we're going to grab the component configuration and delete this spin.toml. And we're going to open, did I delete the wrong spin.toml? No, I didn't. Good. Delete this spin.toml. We'll come into lowercase and add the Rust component, which is going to listen on hello. And this uses a root parameter. Yep, see, hello slash and then the name. So we need the wildcard syntax of ... and then we need to tell it how to be able to build this application like so. Now this is in a different directory. I'm not sure what the spin.toml accepts, if it accepts any sort of configuration for the working directory or whether I need to use cargo to point it. So let's come back to that in a moment. For now, I'm just going to do this. So I can run a cargo build myself and then we'll come back and we'll tweak this to work with the other directory. But right now, I'm not that fussed about getting this to work. So let's go to our Rust application here, where we have a very simple component. And we need to extract this root parameter. So now I have to remember how to write Rust, which means we need name equals request. And this is going to be URL or URI path. And what does this return? This gives us a string. So we are going to want to, well, we can debug this, right? So we can do print path is blah name. And I suspect this is going to print out slash hello slash fermion. And then we'll just return this as is. So let's go and compile this with the cargo build command from the spin.toml. And then on our top level, we can run, nope, in my lowercase, I can run spin up. Oh, I got duplicate IDs. Let me fix that. So this is actually lowercase. Oh, and I still got spin running. My own worst enemy. So now we have our two endpoints. So what we want to test is hello fermion. And if we look at the, oh yeah. So if you want the logs, you have to add the follow all to your spin up. Run this again. And we can see the path is hello fermion. So now we need to tweak this path and remove the prefix. So we could probably do, is there a remove? No, what have we got? Oh, there's a split last. Nice. You will work perfect. Sometimes Copilot is just far too smart, isn't it? So, in the interest of just confirming that this does what we expect it to do, this should now print the path is fermion. So let's close our spin up, run our cargo. Oh, too many tabs. Run spin up, run curl. And now we just get fermion. So this is what we expect. So now we need to take this property, which is the name, and we need to make an outbound HTTP request to the lowercase service and get back the string so that we can produce the correct response to the client. So the way that we work out how to use this is Spin has fantastic examples. So if you come to the Spin examples repository, you will see, you can search for outbound. There's a TinyGo, there's a Rust one, there's some Postgres and Redis stuff as well. So we want to see the Rust outbound HTTP. We go to source and then lib. And here you will see that we can make outbound requests like so. So we're just going to leverage the examples to get what we want. So here we're saying that we want to send a post request to blah with a blah. Now, because these are two components in the same Spin application, we can use relative written, which means that we can say send this to lowercase. We need to define a struct for our outbound payload, which is going to have value string, and we can say let outbound payload equals like so. Now here we're going to have to use Serde to make this serialized to JSON. So the way that we do that is to derive Serde serialize and deserialize, although we only need to serialize a string. But we actually need Serde first. Now this is just Rust, so we're just going to go to our hello cargo add Serde and Serde JSON, like so. And we need some features here, so we're going to have to add the derive feature to Serde itself. There is a way to do that with cargo add, but you can also just go straight into the cargo.toml. We're here, we expand this to say actually the version is here, the features, and we want derive. So we can close that. Our red squiggle on the derive should disappear. And then here we can do Serde JSON to string and then pass in our outbound payload. And I believe the body is an option type. Yep, so we want to pass some like so, and it's bytes. So let's try that. And to string actually needs unwrapped. And then our outbound payload needs to be a reference. Phew. Okay, so this is how we send an outbound HTTP request in Rust. And in fact, now that I think about this, I should have done these services the other way around. Because in TypeScript, all I would have had to have done is a very simple fetch. However, I like to make things hard for myself. So we've parsed the path, composed our outbound payload. We're sending an HTTP post request to a relative path because the Spin components are all in the same domain, the same URL. We put some JSON into the body and we have some response. So now we have to say that, excuse me, let's derive deserialize of an inbound payload, and we know that it's not value, it's message, like so. And then down here, we need to do let, and then Copilot is going to write all my code for me. So we're doing res.body unwrap, and it's complaining. 30, oh no, it's not. Well, what do we get from res.body? So let's see, body equals res.body. We get an option of bytes, okay, from slice. From okay, that should work. Okay, so we want body dot unwrap. Oh no, it's an option. Okay. Okay. Complaining. I'm going to do from string just because of the structure here. See if that helps. It wants bytes. Oh, come on. You're making me look silly. Saturday JSON from. And. Okay, so we need a byte array here rather than bytes. What does that give me? A vec of u8. Actually, that's not too bad. Let's use that. So v. Copilot Lite. Oh, come on. Okay, so we've got a result object now. That's okay. And you shouldn't just be throwing these unwraps around like that, but you know, I'm going to for the moment. Why are you complaining? This is complaining because body is moved. Gonna clone it. Yeah, why not? This is not great Rust, but I am conscious of the time and I've gone slightly over the 30 minutes, and it's always me with Rust. You know, I write so much Rust and yet I still get tripped up by the simple things. However, this should parse that payload. We should have the value that we need. We need to return our content type, application, JSON, and then we need to print out, what was the spec saying? Oh, I actually don't specify what the output should be. I'm going to have to update that. However, we'll do as it says for now and then see how the test cases feel about that. So we're going to say hello. Too many brackets here. We need a formatter. We can do inbound message. And this is because the format returns a string, and this is complaining. Oh, wait. Too many brackets. Okay, let's compile. So cargo build. Spin up. Curl. Invalid URL. It doesn't like this. So we're going to have to use like so. Okay, good. This is what I expected. The destination not allowed. So spin ships with a whole bunch of kind of secure by default things, and one of them is it restricts outbound HTTP traffic. So you actually have to enable this. So let's find the example outbound HTTP, and if you open the spin.toml, you will see this here. So on the component that is going to make the HTTP request, you have to add the allow HTTP host. Now you can restrict this and say that you only want to allow localhost, or maybe you want to allow google.com or some API that you're calling. That's up to you. In the interest of time, I'm going to be insecure allow everything, which means we can come back over here, do a cargo build, spin this up one more time, run the curl, and now when I pass an all uppercase string, we get the lowercase string back. So we could pop over and do the test hurl. We got all this temp stuff. So let's copy this and bring this back into the mix. Well, let's see what our test case expects. So I've got slightly weird things going on here. Let's remove this. So if we call get hello raw code, and we want raw code. So this is doing a JSON assertion. It expects us to return the message format, so we'll need to make that work. Interesting, they're almost the same. Didn't mean that, but that was accidental. So let's just do one last change where we say, okay, we want an output format. So we're going to do struct out response payload. Just make things hard for myself. We're going to derive serialize, and then down here we'll say output payload, which is an output payload equals, and it is our format hello with our message. And then down, oh, there we go. And then now we want a sum, and we don't need the format. What we need is a Serday JSON toString where we pass in our output payload. And this will need an into to put it to bytes. What have I forgot now? Rust, you annoy me. Trait bytes from result. Okay. Yes. Unwrap into, and then reference. I'm probably making this harder for myself by trying to read the error messages through VS Code. It's actually a lot easier if I were just to run the cargo build from here. All right, spin up, curl, and now we get value. And is it message or was it value? Let's check the test case. Message. So let's fix that. Which is just a small response payload. Oh, outbound payload. Inbound. Oh, I'm using my terrible name and biting me on the ass. This is a response payload. There we go. Which then has a message. Whew. Talk about shooting yourself in the foot. And let's try Fermion. Okay. So if we run hurl, test hurl in the right directory, all of our tests pass. And just to confirm that I saved this file, still pass. Wow, all right. Oh, hello, Chevet. Thank you for tuning in and joining me as I fought through some Rust. Always a pleasure to have you join us. So let's just recap this a little bit. So in order to add another component to your Spin application, you can just use Spin New. The easiest thing to do is to grab the component stuff from the spin.toml and put it into your own spin.toml. You update your spin.toml and make sure the paths are appropriate for where the target or the compiled WebAssembly module is going to live. I said I was going to look up the working directory on the component.build, so let's do that. I don't mind going a little bit over. So let's pop this open. So we want to understand what parameters are available on the spin.toml. So let's see if we can work it out. Let's see, create config. I'm assuming there will be some types in here for the spin.toml file. Assuming config is the correct place for that, which I'm not terribly convinced of at the moment. So let's search for component. Oh, my hands are cold because the heating in this building is broken. Or maybe we'll search for build. There's no build here. So let's take a look at, is there anything here unique? Trigger and build. And there's a spin version. That spin version might be quite easy to find, right? Yeah. Oh, that's a get template source. Okay, we don't want your plugin source manifest. Maybe I was silly to think that would be too easy to find. This is this is plugin stuff actually, which I'm not looking for. Oh, is that a test case? Yeah, it creates loader. It seems promising. Let's go to the loader. Local. You look interesting. Not quite. Why can't I find build? Run the build command. Okay. It's called build component. There's a worker. Thank you. So let's pull this back out to the top. Because what we really want, right, is for the spin.toml to be here and everything else to be defined lower. So this is now going to be, I'm going to regret this again, aren't I? Lowercase target. And we need a worker of lowercase. And then for the hello, you're no longer going to be here. You're going to be hello target. And your build is a worker of hello. So assuming I haven't messed this up too badly, spin.build should build. And spin.up. Oh, you were close. Oh, it's failing because I'm running. Haha. Okay. So with a little bit of running through the code base like a headless chicken, we were able to work out that we can specify the worker for all of our components so that we can say, hey, go run these commands in this directory, giving us a logical hierarchical structure for our Git repository and our multiple components with the spin.toml at the top, which is exactly what we needed. Our tests hopefully still pass if you were running Oh, I'm in the wrong directory. If we were still running, our test still passed. So I will push this code. Let me pop back over. So we took a look at the TypeScript SDK. We wrote a component in Rust. We looked at how to connect the two dots and set up the path-based routing in the spin.toml. We worked out how to set the working directory for each of the builds. We used follow all to get the logs and debug the payloads as we worked through the scenario. We got the test to pass. This code will all be pushed up to my repository. The link will be in the description soon. And I'll see you all on Monday for Challenge 3. Thank you so much for watching. I hope you're enjoying the advent of Spin, and I'll speak to you all soon. Have a wonderful weekend. Thank you.